All right, welcome to Hands-On Machine Learning Engineering and Operation. Today we're going to talk about the model development, and in this module we're going to talk about a lot of stuff, but essentially I want to give you the machine learning engineering perspective on a few subjects like AutoML, evaluation of your model, and especially put a lot of emphasis on dealing with complexity, like how do you go from building a local, let's say, small model, in your local environment or in your local server, like a local computer. How do you take that out and how do you scale that up, to build machine learning at scale? As always, I want you guys to have this in mind here. This is the core modules or like the core pipelines that we're building in this course. We started last time with the feature engineering pipeline. We talked quite a bit about the way that we can go from our raw sample data towards our feature store. And we've put a fair amount of time into coming up with a clean feature store that we have preserved in our data warehouse environment. In this case, we're using Google BigQuery to keep these features clean, to keep these features centralized. And so now all of this work that we put into the feature engineering pipeline is going to be very useful because we're just going to be able to take these features as they are without having to apply any more processing or any more cleaning or anything else. We're just going to be able to leverage the feature store and build our model development pipeline straight on top of it. And if everything goes fine and if we manage to do it correctly, what we should get out of this, if everything goes well, is an optimal model and a bunch of insights into how was this model built, whether we're solving the problem at hand properly, and the hyperparameters that should be a good reference, and the hyperparameter that should be a good reference for how well this model is performing. And so this is what we're going to focus on today. Next time we're going to go over the training and the serving, but for now let's focus really purely on this development and look at it through the lens of a ML engineer. So as always, I want to lay out a few concepts that we're going to be tackling, especially like in the live coding session and in the labs. Essentially, like the first thing that you have to think about when you are doing machine learning engineering is that you're not just there to put, let's say, solution into production or in deployment. You should constantly challenge the way that the solution was built, and you should constantly go back towards making sure that the model that has been built was done properly. And when we talk about tuning here, when we talk about tuning a machine learning model, essentially what we're referring to is this constant trade-off that you might have heard if you come from data science between variance and bias, right? What you want to have is a model that has a very good accuracy or very good score, but that does so in a consistent way and without too much difference in the prediction, without too much variance in the prediction that it generates. So essentially the picture that we want to have, like when we build our model and we deploy it and we start looking how it performs in real life, you want to see whether your model was, trained on proper data, and it's going to be a constant theme of our module. You want to make sure that it's trained on proper data, and that because it was trained on proper data, the bias that it has, so its tendency basically to be wrong or to be right, is quite narrow, like it's quite pinned down. It usually tends to be right, and it doesn't miss in a consistent way in the prediction that it generates. And you want to make sure that the variance in the prediction that it generates is also pretty low, that it doesn't widely differ whether it tries to predict some specific sample or some other sample. Like it just consistently gives you a good prediction. And very often, machine learning engineering tuning and going back to the problem at hand deals with having a solution that has been, let's say, built in a proper way, but that fundamentally misses one of these two things, right? That fundamentally either has a very high bias or has a very high variance, right? That's usually the case, that the solution that has been deployed, when it's put in production and served for the first time in the real world, typically like exhibit some kind of problems because maybe it wasn't trained on the right data, or maybe when it was developed in the lab, it wasn't really realistic and it wasn't understanding all of the problems that were part of the issue of what needed to be done. So what we're going to be doing is we're constantly going to go back towards the the model and making sure, that we can improve the performance as much as we can, and that we bring, let's say, like the total errors, let's say the combination of the variance and the bias error, that we keep them to a minimum and that we iteratively just improve, even as we focus more on the deployment of the model at scale. Now, when we build this model, we will quickly find that there is a lot of complexity that comes with running this model in local, right? Essentially, we're going to try to develop a model in our local computer. Like this is kind of like, I'm working on a Mac, a pretty small Mac, like a Mac that has only 8 GB of memory, a pretty fair chip. It's actually pretty high quality, but still like very, very low memory that's quickly going to bound the way that I can run these models. And so we're quickly going to face a lot of, let's say, scaling issue where I can really train only the model on a few amount of data. And I quickly will want to move out of this local environment so that I can start training this model not just on sample data, a bigger amount of more representative data, and definitely like faster, like by actually speeding up the running process. And so when we talk about this scale or this, let's move out of the local environment and do things at scale, what we usually talk about is combination between horizontal and vertical scaling, right? And this is more or less the subjects that we're going to tackle in the labs. So I want to make this more clear, like what we're going to do. But essentially, when we talk about scaling, we can scale the way that we run things in two different ways. We can, either just move away from like a small machine, like a small virtual server or like a small local computer, and just go into a much bigger machine, maybe a virtual machine on the cloud, or maybe just a big machine that we buy, like some kind of like big server that we purchase, whatever it is. And we're just gonna like run things on a much bigger machine that has bigger, like just more RAM and more CPUs or GPUs. And because of that, just with the sheer size of the server, we're going to be able to crunch much more processing much faster. But there is always a point where you reach a decreasing, let's say, vertical scaling. Like you never really scale indefinitely the size of the machine on which you run things. You're always going to have at some point, if you have large amount of data and a pretty complex problem to solve, you're always going to have to implement some kind of horizontal scaling, which doesn't really mean, growing the size of your machine anymore. It really means instead of growing the size of one machine, let's just put a bunch of small machines together and let's distribute the workload of the processing that we are doing across this machine so that we don't really require only one of them to do a huge amount of processing that it won't be able to do because it has memory and computing limits. Let's just spread the work so that each one does a little bit of processing, and then we put all of this together so that we make sure we reach the final solution that we would have reached if we had a big machine of unlimited size, basically. And so horizontal scaling is pretty awesome because you have no hard limit on the amount of machines you can chain together in some sense so that, kind of spread the work and have them do a bunch of different small processing collectively. This is quite similar to what we've seen already in the feature engineering part with the worker, the pool of worker that we set up to speed up the API calls that we were doing. So here it's pretty similar, but here instead of parallelizing the workload or spreading the workload in a pool of local workers among the cores of our own computer, instead of doing that, we're just going to parallelize or spread the work across different servers, and we're going to use pretty advanced technologies to do that. The last kind of scaling that there is, just to be complete here, is replication or sharding, and this is much more relevant in the context of databases and things like this. So we're not really going to spend too much time on this, but yeah, if you have the vertical scaling and the horizontal scaling in mind, then I'm pretty happy because I'm going to be able to talk about this concept later in the labs without having to come back here. So this is what we're going to do at some point, right? When we, after having scaled vertically by creating a much bigger server on Google Cloud, which we're going to be doing today, the next thing that we're going to do is to really set up a bunch of small virtual servers together that are going to be coordinated by a pretty powerful technology called Spark. And you will see that this is gonna like allow us to launch basically a program that's gonna train our model, and it's gonna abstract virtually like all of the management basically of those servers, all of the management of those nodes that collectively, when they work together, will produce a huge amount of processing and will be coordinated to return to us our trained model. So I just wanted to introduce this technology that we're going to see very, very quickly, especially we're going to focus on Spark, not really on cloud data flow. And you will see that it's pretty powerful stuff in the context of machine learning engineering. And so to kind of like really pin down, nail the mental image that I want everybody to have in mind when we talk about complexity here, we essentially talk, like, especially in the context of this course, we talk about complexity, and we talk about like dealing with complexity. We talk about like leveraging a bunch of services, a bunch of technologies from cloud computing platforms that are gonna allow us to focus on code, focus on development, just do our thing, and not really have to worry too much about the way that we store our data. Well, we've actually already seen that. We've already seen that. We spend a huge amount of the feature engineering pipeline code, but when it came to really store the feature store in a good environment, we just had to do like a small lab, and we just had to do like a few clicks to create a Google Cloud BigQuery datasets where we could store our feature store. And we stored only 500,000 rows as our training set, but we could have stored like unlimited amount of data in the storage space. So that's pretty great, and it allows us to deal with the complexity of storing data already. But we will see that after this module, you will understand how we can leverage, let's say, virtual servers to do like much more advanced computing that we cannot really do in our local environments. And this is going to be based on a lot of technologies, like if you're using Amazon, like on EC2, if you're using Google Cloud, the computing is going to come, from virtual servers, and when you get them to work together and you deploy them, you can quickly reach the point where you need some technology like Kubernetes and stuff like this. Then we're going to be at the later stage when we go, much more towards the serving and things like this. We're going to see that we're going to be able to package quickly applications and again deploy them at scale on services like Google Cloud Functions and things. And finally, we're going to be able to do like machine learning, like automated ML and automated machine learning with some services like Vertex.ai and things like this that Google is providing us. So all in all, like the main component of building large-scale machine learning system are going to be built on top of a lot of cloud services that's going to allow us to accelerate a lot the stuff that we can do. And again, that's kind of like the picture that I wanted you to have in mind as we get started with this module on model development. All right, so I hope you're excited. Let's get started.